Thank you for access to this webinar, Asphalt roofing spilling failure for shingle system, subjected to high wind conditions for a viscoelastic sealing material response. My name is Aneuris Hernandez. It's a pleasure to stay here with you. I'm a structural engineer, and well, let's start with this webinar. After all, I want to start talking about CAE Solutions. CAE Solutions is an in-receiver partner for CivilFEM 2017, powered by Mark, and CivilFEM for ANSYS. We are a consulting company that provides specialized solutions in computer-aided engineering according to the needs of our customers in all areas of civil and structural engineering. Also, we provide continuing education with PDH and the online FEA master degree. Our customers are our top priority. Our technical team is composed of experts in civil and structural engineering solutions with over 15 years of experience in consulting service practice. What is CivilFEM? Okay. CivilFEM basically it's a CAE productivity tool that works for you. All you need is included in one software package. CivilFEM powered by Mark is a complete software that combines the easy of use of modern graphical user interface environment with multilingual analysis tools for professional and academic users using the Mark powerful calculation engine solver. CivilFEM is able to perform complex high nonlinearity analysis. Forensic engineering is the topic for today. As you know, forensic engineering is the investigation of structures that failed or didn't operate as intended. The main purpose of forensic engineering investigation is to determine the origin and cause of failure, as well as the rehabilitation and maintenance to improve performance or life of the structures. The advanced nonlinear analysis capability of CivilFEM plus code and standards verification make it a unique tool for forensic engineering, structural failure analysis, and design rehabilitations. There are so many cases of study for forensic investigation with CivilFEM. You can see here we have different cases of a study for forensic engineering. First, in the case with the letter A, we have a beam column reinforced concrete connection. This case was made to check the failure pattern in this reinforced concrete joint under cyclic seismic load. These results were consistent with the real damage in the picture here. Note in this analysis, the steel bars were modeled inside the concrete, transmitting any friction forces between the concrete and a steel bar. This is a great capability in CivilFEM. You can just, using one tool, you can insert the reinforced steel bar inside the concrete and see what happened with the bars and the concrete. Also, another great capability of CivilFEM is the contact between different elements. In this case, the beams were modeled using contact face to face with the adjacent column member here. Also, the cracking and crushing were introduced in the material properties. Also, the stress and strain material curve were used in this specific example. Here we have another case. In this case, note the bolts. These are gilded showing plastic deformation in each load increment. Also, note the extent of plastification in this other picture around the column. Okay. This another case is another real case was in the Hyatt Regency Hotel. In this case, the collapse occurs in the vertical continuous walkway. This was in 1981, killed 114 people. Okay, in this case, how you can see here, the analysis with CivilFEM confirms the failure in the connection. Finally, here we have another case of collapse in the airport terminal in Paris, with 6 people killed. Here we have other cases, one for masonry wall. In this masonry wall case, you can see the detachment between each blocks and the joint of mortar. Also, you can see the reinforced steel bar inside the masonry was modeled, and is another great capacity in CivilFEM. You can model the foundation interaction with the superstructure, and also you can model the soil below your foundation. If you want, CivilFEM have a library of different type of soils. Here in the case B, we have another case of reinforced shear wall, nonlinear analysis with different type of steel bar configuration. Well, how I said before, CivilFEM is great to model any type of soil. This is another case of a study with CivilFEM of a slope stability under seismic load. Note with CivilFEM is possible, again, model any type of soil. This analysis in this specific case is showing the slope instability and plastic soil deformation failure line, how you can see here. And here below is showing the slope instability with rehabilitation. Okay. Advantage of using CivilFEM. First, the user can involve different type of nonlinear soil structure interaction. Some type of nonlinear release source are material yielding in superstructure elements, yielding of soil, base uplift or separation of foundation, yielding of foundation of structural elements. Also, the user can evaluate these nonlinear effects using response history analysis performed in the time domain. Also, the user can define different type of contact between soil and structure. Application of direct method to perform SI analysis or soil structure interaction analysis. Also, consideration of secondary effects like temperature creep and shrinkage. Construction sequential analysis to see the effect of excavation, and other things like pre-stressed concrete and seepage analysis, buckling analysis, and another type of problem for structural engineers and civil engineers. Here we have different models of soil and structure interaction by simply define the structure, foundation, and soil underlying interact through any type of load and distribution. I would like to start explaining some important information regarding to this webinar. How you know, conventional asphalt shingles typically utilize a self-sealing adhesive strip which bond the lower roof shingle to the one placed on top of it. Here we have the different components that are normally the roof contain, like shingle, roof panel, underlay material, nails, and self-sealing adhesive strip. There are different failure models in the adhesive with the shingle. First is the cohesive failure in the adherent. Second is adhesive failure, and finally the combine of both failure. In this webinar, we will analyze the second mode of failure. In this case, is an adhesive failure. Okay, we will analyze the adhesive failure type in this webinar. Since the sealant strip material is a form of bitumen, it falls into the category of viscoelastic material. This webinar addresses the time-dependent response of the sealant material used in asphalt shingles. The viscoelastic properties of the sealant material were characterized through the several creep compression tests. The resulting viscoelastic properties were then used to create our finite element analysis models in order to simulate the transient response of single sealant asphalt shingle structure subjected to uplift pressure loading that they would encounter during maybe a category 4 hurricane for an extended period of time. Okay. Also, we will use both curve of stress strain for shingle strain and sealant stress strain. We will model both curve in our finite element analysis models. Okay. Here we have the mechanical schematic of shingle one-layer asphalt roof shingle system. You can see here we will have two models. First, we will have this model with the sealant below in connection with our shingle. Okay, and we will apply the uplift load. You can see in this picture. Okay. Also, we will model another case without the sealant material. Here we have the geometry dimensions that we will use in our models. How include this type of analysis in your forensic claim? It's of special interest to engineers to know the cause of roof damage, and more recently for hurricanes. We all know that the main effect of the intense winds on the roofs produce the detachment in the shingles produced by wind force cause the subsumption or uplift. The failure process begins with the sealant and then passes to the nails. The main objective will be to analyze the force of the wind that produced the failure of the glue sealant, and then to analyze the free condition of the shingle without including the sealant. with the main objective to see the detachment of the shingle in the nail zones, or to see the plastification of the material in the nail area. Well, now we are ready to start with our model in CivilFEM. Well, here this is our first model. Before to start explaining about this model, I want to give you a brief review of the different tools and commands used in CivilFEM. We have different tabs here in CivilFEM. This first tab, environment, is used to define basic parameters like coordinate system. We have here some code, standard code for design concrete, different code like ACI and ASHTO, and also we have different codes for steel designs and for pre-stressed concrete. Also you can change the units system how you prefer. You have different model units, imperial, international system. Also you can use your own system unit and define the units here. Okay, another tools like measures, and you can create reports. The second tabs is geometry tabs. This tab is available to create any type of geometry that you have. Okay, you have different type of tools like curves. Here you can create line, polyline, arc. Also we have different tools to create surface in CivilFEM and volumes and others. There are different ways to create geometries. You can use these tools, or you can just import from the XF file, or also you can use Python. Python is include with CivilFEM. Okay, in other webinar we will show some things regarding Python. Well, we have another tab here, model. The model tab is basically used to define all these different type of materials and also cross sections. Okay, CivilFEM have different libraries of concrete, steel, soils material that you can use at any time. Also you can create different type of sections. CivilFEM have a library too of different steel sections that you can use, or just you can define a generic section. Well, this other tab is the mesh. Depending of your model, and your structural elements, you can assign different type of mesh at your model. You can assign mesh to a beam, truss, shell, soil, cable. Also, you can use mass connections. This insertion tool is a great tool in CivilFEM. You can just using this tool, you can insert there are still bars inside the concrete. Also, you have different type of spring that you can use in your bottle. And finally, this is another great tool. This tool is used to assign different type of contact between different structural elements. Well, we have here the options to assign your mesh and clear your mesh. This is another tab, loads, basically, is to assign loads and boundary conditions and define different type of load case. Solve is to solve your model, and results to see the results and view different options to view your model. Well, you have two options to see your model. In this case, this model is already meshing, but here you can see your basic geometry using entities. Okay, here in your right hand you have the entities using in our model, different points and different surface and lines without meshing, with any meshing. Okay, just the geometry. Okay, you can see here we have the materials already defined and some structural elements and the contact and loads, boundary conditions, and load cases. First, I want to show you the materials that we use. Okay, here we define basically two materials, one for sealant and another for asphalt shingle. For sealant, this is basically the properties that we have defined for this material, and for asphalt shingle, we already defined the curve of stress strain used for this material. Okay. Well, here we have the structural elements. What is the structural elements? Well, the structural elements basically consist in elements that have already assigned the properties. In this case, for example, we have this structural element with material assigned and thickness. Okay. Also, each structural element have the mesh control. In CivilFEM, we have available different options to perform our mesh. In this case, we are using a quadrangle mesh with these parameters. Okay. Well, once you define your different structural elements, you can perform your mesh, and you can see here we have a continuous mesh, and this is the shingle, alpha shingles, and this blue part consists in our sealant model. Okay. Well, Now I want to show you the boundary conditions that we already defined. Well, in CivilFEM you have different alternatives to define your boundary conditions. You can define single boundary conditions, linear, surface. You can assign displacements and displacement, a single displacement, displacement on a line, displacement on surface. In this case, we already define some boundary condition applied to the surface below our asphalt shingle. Let me show you here your boundary condition. You can see here, okay? Okay. Well, regarding to loads, we have two type of load: gravity and wind pressure. Remember, we apply the wind pressure in the vertical direction. In CivilFEM, you can define different type of loads. How I said before, you can apply single punctual loads, single moments, linear loads, surface loads, point moving loads, temperature, and others type of loads. Okay, I'm going to show you the loads used. Here we have some wind apply in the surface of our shingle. Well, for loads, we put a high wind pressure, how I said, in vertical direction to cause uplift and the ceiling detachment. Basically, the objective was determine what is the necessary pressure that cause the ceiling failure. This is our main objective. Okay? Repeat. Our main objective was determine what is the necessary pressure that cause the ceiling failure. Okay? To do that, we put a high wind pressure in this direction. Okay? Well, we have this load case with this load and boundary. Okay. Well, how we are doing a transient nonlinear analysis, we need to specify the calculation time, how you can see here. Here, I want to show the load case consists in the boundary conditions basically, and plus the wind load. Okay. Well, for solve this problem, we are considering large deflections because we are doing a nonlinear analysis. Okay, here we have a different type of parameters to solve this specific problem. Okay, now we are ready to show the results. Let me clear our model. Well, first I want to show the node results in vertical direction, the displacement. CivilFEM, you have different type of results. Basically, we have node results, we have element results, end results, and element results. Okay, for node results, we have displacement results, okay, contact, normal stresses, and another type of results like total rotation, total displacement, and etc. And also for end results, you can see the moment diagram, force diagram, shear force diagram, and another type of results here. You can change your units at any time to see the results. Okay, for no results, you can show the displacement here. Okay, but in this specific study, I want concentrate in the solution here. I want to see what would happen in the in this zone with the sealant in contact with the this asphalt shingle. Okay, I want to see what is the pressure of the wind necessary to detach this shingle asphalt. Okay, for do that, I need to see the three component of contact normal stress. Here it is. Okay. Well, in this first step, okay, we can see the stresses in the ceiling strip. We want move forward to see what happened. Note in the step number 7, our asphalt shingle was detached. Okay, we can see this using animation to see better this specific condition. I will load all the results. Let me use a scale the number 10 and put here the component C component of contact normal stress here. Launch this animation to see. Okay, note this is very interesting. see how the wind forces are uplift our asphalt shingle piece. Well, how we want to see what is the necessary wind pressure to do that. Okay, to see that, I want to plot a graphic to see the variation of the displacement and pressures. Okay, let me show you that now. Here in history plot. Okay. You can evaluate your response in any point that you want. For example, in this case, I want to use this point to see what happened here. Okay. The number of this point is 27462. Okay, I will include here another axis for my graphic. The name will be displacement. We'll use here no results, and for the node 27462, and I want to see the displacement in vertical direction. Okay, I will plot that. How is the variation of the displacement of this node, specific node, with the time? Okay. Okay, how you can see here, this node, the start to displacement in vertical direction in the in this specific time. But it's most special interest for me evaluate another graphic relating the displacement with the pressure load. I will add it another axis here. In this case, name will be pressure. Okay, now I need in this case to see the pressure. I will need the element results. Here I have pressure. In this case, I need put the number of the element that I want evaluate. Okay, in this case, we use this element. The thing is this element here. One of this. Okay. Well, I will use in the x-axis, I will use the pressure, okay, and I will select the displacement to perform my graphic. Well, here, or you can see in this graphic, we in this specific model, we need approximately 90 100 Pascal to create the detachment between the ceiling and asphalt shingle. Okay, this is approximately equivalent to 180 kilometer by hours. Okay. Well, now I want to show you the other model with the nails in this area to see if any plastification of the material occur near of the nails. Well, here we have our second model. Okay, you can see it's the same. The same geometry. The only difference is that we have modeling the nails in these areas. Okay. Well, note that we don't have any ceiling here in this part. We are assuming in this second stage we don't have any ceiling resistance and the wind attack in the vertical direction, and we want to know what happened now in the nails area. Okay. This is our low case condition here. Okay, boundary conditions and wind load applied in vertical directions. Well, let's see the results for this model. In this case, is a special interest to see the equivalent plastic strain. Remember, it's very important to input in the material properties the nonlinear equivalent plastic strain, you know, to see the plastification of the material. Well, want to see the equivalent plastic strain? In the first step, we don't have any plastification near of the nails. In the second step, four, five. Well, here I start some plastification here. This means that maybe our shingles is broken in this area. Okay, in this specific zone. Okay, in the same way you can see determine using the history plug what was the necessary wind pressure to occasionate this specific condition. Well, that's all for today. Thank you very much for assist to this webinar. And if you have any question, feel free to contact us. Our email is contact@ CAE Solutions company. Also, you can visit our webpage that we have all the information regarding to this software. And thank you very much. I hope see you again in our next webinar.